In this video, we're going to look specifically at some vocabulary and key terms. We're looking at the language of algebra. So we start with a variable. So a variable, in our case, it represents an unknown. Okay? Generally speaking, variables are letters in the English language. Sometimes they'll use sometimes it's in Greek. We've talked about this a little bit already. Algebraic expressions. Okay, so an expression, specifically an algebraic expression, has at least one variable and there is no equal sign. We go to equations. Okay. Equations are an algebraic expression that contain an equal sign. Another way we refer to it is a mathematical sentence. Just as your sentence in English has to have a noun and a verb and can have other parts of speech, our mathematical sentences have equal signs or inequality symbols, addition, subtraction, multiplication, division, and all of that. And we have, of course, our inequality symbol. So an inequality is a math sentence that instead of it being equal and we calling it an equation, has an inequality symbol and we call it an inequality. Some other stuff we need to look at. Term called constraint. So a constraint is a limit or restriction we put on an equation or inequality. So generally constraints we'll view as, we'll say x not equal to 2, or it'll say x greater than 4 or something like that. The constraints limit the input or domain. Okay. Now we have a term. Okay. So a term is a variable, number, or product of a variable and number. Okay. And terms are separated by addition. So 2x is not two terms. That's one term. 2x plus 4x squared plus 3, that's three terms because it's separated by addition. Okay, we've talked about an equation that contains an equal sign, an expression not containing an equal sign. Now, with an equation, in this class, we are going to assume that it is true until we prove it false. And what I mean by that is if we have an expression, say 2x plus 3 equals 5, we will assume that that statement is a true statement until we do math and find out that it's false. Okay, when we do that, we're looking for truth values or values that make something true. So let's look at some truth values. Okay, so this one, let's look at this first one. 13 plus 4 is 17. 7 and 11 make 18. So what we do in this case is we put a line through the equal sign and we say 17 is not equal to 18. This one is false. So as I said before, when there's an equal sign, we make the assumption that it is true until we prove it false. So in this case, we've proven it false. So let's look at our next one. So So this side is 9/8. And that's going to be equal to 1.125. Okay, which those two are equal. So this one is true. Then we do our last one. Remember, parentheses first, following our order of operations. So we do what's in here first. So we get 10 squared equals, let's go to the, so PE, parentheses, then exponents. So this side is 36 plus 16. So this is 52, and this side ends up being 100. And that one is false. So hopefully that helps illustrate to you truth values and what those are. So what I'd like for you to do in your notes is copy this table down. And then answer the mathematical expression part. Okay, so what is 9 increased by a number? I'll give you a hint with the first one. So that's 9 increased. So that means addition, and we have 9 increased by a number. Okay, and do that for the rest of those, and we will talk about it in class. Now we're going to look at understanding polynomials. Okay, with poly meaning many, and a nomial being a term. So the types of polynomials that we normally give name to are just the first three. So we have a monomial, which is one term, and mono is singular, meaning one, and think of monocle or monarchy, monarchy meaning one leader. Okay. Next one we look at is binomial, with the prefix bi, meaning two. You think bicycle, this is two cycles or two wheels. Trinomial, prefix tri means three. So think tricycle or think trident. Trident has 3 points. And then the generic term polynomial is any number of terms, but usually we use polynomial to describe things with more than 3. If you think of a polygon, polygon generally will describe anything above a square or a rectangle. Poly means many. Okay. So some important facts about polynomials. So every monomial has something called a degree. So the degree of a monomial is based on the sum of the exponents. So if we look at 2x to the fifth, there's one variable, one exponent. So we say that term is to the fifth degree. Now if we have two exponents with two variables, you add them up. So 4x squared y to the fifth, we say is a 7th degree monomial. Now for a polynomial, polynomials can also have degrees. A degree of a polynomial is determined by the term, the monomial, with the highest degree. So if you look at our example here, 3x to the fourth minus 5x squared plus 9x to the 7th. Well, we would we'd look at our terms, put them in, well, we look at our terms and we see which one has the highest value. Well, this first one is 4. This next one is 2, so that's lower. So 4 is our winner right now. And then our last one is 7, and that's the highest. So this is a degree 7 polynomial. The next one we do the same. So this one is 8. This one's 5. This one's 7. So that particular polynomial is an 8th degree polynomial. So that's another way we can classify polynomials, is by their degree. So if we look at some polynomial practice. So this first one, we look and we see so there's no addition. So with no addition, we can label it as a monomial. And now we have to determine what the degree is. So we're going to add the exponents. So we say this is a monomial of degree 13. We go to our next one. So I see two addition or two separations. So this one is a trinomial. And now we determine the degree. So this term is a 4th degree. This term is a 2nd degree. And this term is a 5th degree. So our highest degree is 5. So that one's a trinomial of degree 5. Let's look at this last one here. So again, I see two separations. So this is a trinomial. And of which degree? Well, this one's 8. This one's 5. This one's 7. So this is a trinomial of degree 8. So that is how we can determine the degree and type of polynomial. Now there's a special form that we write polynomials in, and that's called standard form. So standard form is where we write polynomials in descending degree order. So what that means is highest to lowest degree. So let's see what that looks like with that last example we looked at. So we have 19a to the 6th b squared plus 8ab cubed c minus 27a to the 7th. And we said this term was degree 8, this was 5, and that term was 7. So we want it in descending degree order. So the 19 stays, but the negative 27a to the 7th needs to move. So it's going to be minus 27a to the 7th, and then 8ab cubed c. So this is now in standard form. Okay. Once it's in standard form, there's a few additional things that we can look at. We can first and foremost look at what's called the leading term. So that's the term with the highest degree. So that becomes our leading term. And the other thing we can look at is what's called the leading coefficient. So we look at our leading term, and the coefficient is the number in front of a variable. So we call that the leading coefficient. So here's one for you to practice. So in this video, we looked at interpreting the parts of an expression, specifically vocabulary. So looked at terms, naming polynomials, and then how to get polynomials in standard form and determine what their degree